Question 3. Differentiate the following function with respect to x using suitable rule. As you can see, for part A, we have y of x equals to a product of e to the power of 2x and x cubed plus 6x minus 1. So if you want, I can highlight this to be first part to be this e to the power of 2x, the first part, and then for the second part is this part. So based on this, we can simply use product rules. Y equals to part A, e to the 2x multiplied by x cubes plus 6x minus 1 with this part to be our u and this part to be our v. So multiplication or product between u and v, you can use product rule for differentiation. So in this case, y prime will be equals to u prime v plus v prime u. So if u equals to e to the 2x, therefore u prime will be 2 e to the power of 2x derivative. And then if our v equals to x cubed plus 6x minus 1, therefore v prime will be 3x squared plus 6. So based on the product rule, dy dx or y prime equals to u prime, in this case 2 e to the 2x times u prime times v, which is x cubes plus 6x minus 1 plus v prime, which is this one, put bracket for a better visibility, v prime times u to be e to the 2x, put e to the 2x. The next thing is simply simplifying the expression. I think one of the common terms between this and this will be e to the 2x to be the common terms, and then the rest is just multiply everything inside. So for example, 2 become 2x cubed plus 12x minus 2. That's for the first term. Oh, sorry, cancel the minus 2, forget, and then continue. The next one will be plus 3x squared plus 3x squared plus 6. So upon further simplification, dy dx will simply be, again, 2x cubed will be alone, 12x will also be alone, I think, yeah. But we use the 3x squared first. We have 3x squared, so plus 3x squared, and then plus 12x, I believe. And then we have minus 2 plus 6 will become positive 4. Okay, that will be the answer for part A. For part B, y equals to cos pi tangent ln x. What is the derivative of this function? So in this case, we need to be careful because cos pi is a constant, which is equals to -1. So the only variable in this case is simply x or ln x. So we can substitute our ln x to be u to simplify the problem. So the question really be equals to y equals to negative 1, okay, negative tangent ln x, let's just write down and then we let our u to be equals to ln x, and we can take the derivative of u with respect to x first. Derivative of u with respect to x, and derivative of ln x will simply be 1 over x. So the original problem will becomes y equals to negative tan u. So in this case, we can take the derivative of y with respect to u. So derivative of tangent is secant square. So in this case become negative, maintain the negative sign from above. In the equation, derivative of tangent u is simply secant square u. So we, in order to find out the derivative of y with respect to x, we can use a chain rule. Derivative of y with respect to x equals to dy du multiplied by du dx, which we already have. Derivative of y with respect to f, dy du is dy du is this part here, negative secant square u multiplied by du dx, which is 1 over x. So there we go. The first derivative is simply negative secant square u, which we can substitute back to be ln x in brackets all over x. This will be the final answer for secant square for dy dx, which is a negative secant square ln x all over x. For question 3, part C, we have y equals to 3x square minus 2x plus 4 all over x cubed plus 1. So in here it's quite clear. It's simply u over v, if you like. So the yellow part here will be our u, and the green part here to be our v. So we can let our u to be 3x square minus 2x plus 4, and our v is, let me just write the v on the other parts. Our v is x cubed plus 1. So we have, in this case, y to be equals to u over v. Therefore, dy dx, because both of these u and v is in terms of x, can be expressed as u prime v minus v prime, the derivative of v, times u all over v square. So substitute everything, dy dx, because both u and v is in x, so we can take the derivative with respect to x. U prime, in this case, we have not done the u prime, which is this one here. U prime will be equals to 6x to the power of 1 minus 2, whereas our v prime will be simply 3x squared plus 0. So substitute everything back. U prime will be 6x minus 2. Put the brackets to avoid minimize any mistake. To avoid mistake. Time v will be 3x squared minus v prime is, sorry, I made a mistake, see. V is x cubed plus 1. It's very easy to make mistake. V prime will be 3x squared times u is over there, 3x squared minus 2x plus 4 all over v squared. So 3x cubed plus 1 square. Uh, what we usually do is to simplify the problems. Okay, so multiply all of these and then all of this with this and then find the common variables. Okay, so if we do that, let's just do it. So 6x multiplied by x cubed, okay, will become 6x to the power of 4. So I use a red marker. This multiplied by this, and then the next one multiplied with this plus 6x. Sorry, this is black color plus 6x, and then the next one is minus 2 multiplied by x cubed. So we got minus 2 x cubed, and then minus 2 plus 1. Sorry, multiplied by plus 1 is simply negative 2. Leave everything now because we multiply individually. So we have 3x squared. This u here square here belong to the numerator. Yeah, careful. So we have 3x squared multiplied by 3x squared become 9, negative 9x4, and then 3x squared to x become positive 6x cubed, and then negative 3x squared on 4 become 12, in this case negative 12x squared. We don't need to expand the first on the denominator, so just maintain x cubed plus 1. So in here we have 6, negative 9, we have negative 3 then, negative 3. So dy dx equals to negative 3x to the power of 4, and the rest should be, for the to the power of 3 we have 6 and minus 2 become 4x cubed, 4x cubed, and then for square we have negative 12 only, and then for x we have only 6x, and then for constant is simply negative 2 all over x cubed plus 1. So that should be our final answer, negative 3x4 plus 4x cubed minus 12x squared plus 6x minus 2 all over x cubed plus 1 to the power of 2.